Hello everyone, this is Professor Chan from Math 1240 speaking. We're going to continue on with Chapter 6 material. I want to go over inverse norm and then binomials. So let's talk about this here. So if I look at problem 8, okay, how do I know this is what's called inverse norm? So inverse norm, it's normally distributed. And then what's also the thing that we have to realize is notice that we're being asked to find score as opposed to percentile. So if you notice, right, we're being asked to find a specific height. But if I look at the following up here, right, they'll be like, what, so example, if we look at a problem that we did before in the last video clip, right, we're being asked to find what percentage of scores are above 733 and below 333, right, or what percentage of scores are like below 400, okay? So if you're trying to find a percentage of something and it's normally distributed, you're doing normal CDF, okay, or normal distribution. Now notice it's flipped, the problem we're doing right now. Sorry. Notice this one, you're asking to find a score, but you know the percentage, okay? So we're going to use a formula, if I'm doing it by hand, called inverse norm. So there's two ways, okay? If you've been watching the PowerPoint, Tyler shows you how to do it through calculator. I'm going to show you how to do it by hand. And once again, either one is fine. So inverse norm is going to be the following. It's going to be z is equal to mu plus, or sorry, my bad, not z. It's going to be x is equal to z times sigma plus mu. And let's remember, right, mu is your mean and sigma is your standard deviation. Okay? So let's talk about this. So what do we know? Our mu is 65. That's what it says right here. And then we also know our sigma is 2.5. Now the tricky one is z. We have no idea what z is. Now it says what? Now the thing is though, they're giving us that we have a 20th percentile. Okay, now let's understand what a percentile represents. Percentile means that you're to the left of, right? So 20th percentile saying, in this case, you are taller than 20% of the population. Okay? So if I look back at my table, let's talk about this right here. I'm actually going to go opposite if I'm doing this by hand. So what I'm going to do, instead of looking at the columns, I'm looking at the number specifically. Okay? And remember, you have two pages. You have, so there's, when we do normal CDF, right, there's two pages. There's one page regarding all the negative z-scores, and then we have a page dealing with the positive z-scores. So what I'm going to do this time, and let me zoom out a little bit. What I'm going to do here is when I look at this, I'm trying to find the number that's closest to 20%. So if I look around here, 20% is the number closest to 20% is 0.2005. Okay, and I'm like, well, what z-score corresponds to 0.2005? It is negative 0.8 and 4, so it's negative 0.84 here. So 0.2005, do you see that? So I'm going backwards as opposed to normal CDF. Normal CDF, right, we look at the two ends and then we converge them. Inverse norm, I'm looking at the percentage and I'm trying to find the two numbers that correspond. So in this case, it's negative 0.84. So my z is negative 0.84. So this is going to be x is equal to negative 0.84 times 2.5 plus 65. Okay, so I have negative 0.84 times 2.5, and I'm going to add 65. My answer is going to be 62.5. Okay. Sorry, 62.9, my bad. Okay. Now let's talk about this right here. Okay. When you look at your answer, it should kind of make sense because, right, 62.9 is smaller than my average, right? If my average will be at the 50th percentile, so if I'm doing a 20th percentile, it should be smaller, right? So again, you want to kind of use number sense to kind of help you out. Okay. Now, okay, and just want to clarify, if you want to do your calculator, you're going to do second vars inverse norm. Your area, you're actually going to do 0.20, and then your mu and your sigma is going to be the same. And hit enter, and it's very close, right? So you can also use your calculator, right? And you can say inverse norm, and then you'll type in, you'll write in the three things, right? So you'll write in, you'll write in 0.20, 65, 2.5, and notice we got, I think, 62.89, which is fine. Okay. So we are off by a tiny bit. That's okay. For following, and technically this does round up to 62.9 as well. Okay. Okay. Now, you do have to be really careful sometimes. So let's say, actually, let's look at number 9 here. So when they say 98th percentile, right, again, they're saying the bottom 98%, okay? I do want to talk about this as well. Sometimes they'll say something like, find the top 2%. You should realize both of these actually have the same z-score, okay? Think about it. If you're in the top 2%, that means you're better than 98% of, if you're in the top 2%, you're better than 98% of the population, okay? So do be very careful about that. And remember, when we're doing the table, we're always going to the left. So if they say, like, find a score that corresponds to your top 10%, you're actually going to find a z that goes for the bottom 90, okay? One other thing, too, they give you this, N69, 3. You have to realize this is saying your average is 69, and your standard deviation is 3. Okay? So what I can do for this one is I can do inverse norm, right? And I can do 0.98, 69, 3. I'm going to enter this in my calculator, see what I get. Okay, and I get 75.16. Okay, I can, again, also do it by hand. And I can do the following here, where I'm doing to find my x value, which is z times sigma plus mu. Sigma is, right, 3, mu is 69. Now my z-score, I go to my table and see when it corresponds to 0.98 on my table, okay? So if I look at my table here, right here, the one that's closer to 0.98 is this one, 0.9798. And I look across, it is 2.05. Okay. You should probably also print out this table so you can follow along a lot easier here. So my z-score is 2.05. Sorry about that. Okay. And I actually get 75.15 if I throw this in. So this is actually really close. Okay, so make sure you know the difference between normal CDF and inverse norm. So let's just reiterate this again. So normal CDF is it's normally distributed. You're given the score, you're trying to find a percentage. Inverse norm is the opposite. They'll give you the percentile or percentage, and you're trying to find the score. The last thing I want to go over quickly is kind of binomial distribution. Okay, so you have, if you have already looked at the PowerPoint, okay, you have two things. You have what's called binomial CDF and binomial PDF. Okay, so what does binomial PDF mean? PDF means exactly. Okay, binomial CDF means up to. Okay, it's very similar to normal CDF as well, right? Normal CDF also means up to that point, right? And remember, you're reading to the left, right? The table always goes to the left, okay? So binomial CDF is the same thing. So CDF means all the way up to that specific point, okay? Now, remember with binomial CDF and PDF. Binomial CDF, remember, if you look at your PowerPoints, the rules is that it is discrete, right? Discrete, if you guys remember, means that if it's discrete, that means it is not connected. So what do I mean by that, right? It has to be whole numbers. So example, the number of children you have has to be discrete, right? You have one child, 2 children, 3 children, 4 children. You cannot have 3.5 children, right? So that is discrete, okay? Normal CDF, right, is continuous, right? Because if you're measuring like weight, you can go in between, right? You can have someone weigh you could have something weigh 1.5 ounces or 1.23 ounces, okay? But you can't have a continuous, right, number of children, right? Because they go up by steps. They go up in whole numbers, okay? So binomial, right, is discrete. Remember, you also only have 2 options, and it's independent, and then your trials are always the same as your theoretical. Okay, so make sure you go to your PowerPoint and remember your 4 rules of binomials. Okay, and this is important because you want to understand when to use binomial and when to use normal, and then when to use inverse norm. Okay, so how do I know that I'm using binomial? Okay, other than the fact that it tells us right here. Okay. So let me explain. Let's look at this problem. Let's assume it doesn't say use binomial probability distribution. Okay, so how do I know it's binomial? Okay, so notice you're being asked to find exactly 4 of the sample people on the tablet computer, right? So you're trying to find the exact number of people. Notice that is discrete, right? So you can either find like 1 person, 2 person, 3 person, 4 person. You cannot have 3.5 people, so it has to be discrete. The other big giveaway is if you notice, right, you're going around and you're asking people if they own a tablet. Binomial, right, the word bi means two, right? If you ride a bicycle, you have two wheels. Binomial means you only have two options, okay? So you're going around, you're asking people if they own a tablet, right? So their answer is either yes or no, right? Yes, I own a tablet, or no, I don't own a tablet, right? There's no like maybe or in between, right? Now, if I ask someone how old they are, right, that's no longer binomial because, right, there's more than two choices. Someone could be 27, someone could be 51, and so forth. Okay, so binomial, you have to realize it has to be two. The question that they're asking always has two responses, generally a yes or no, right? So it's like I own a tablet or I don't own a tablet. Okay, so the big one is, so part A says we're trying to find exactly 4. Okay, so that is a big giveaway. So that means it's going to be PDF. Now, binomials, you cannot do this by hand. You have to do this by your calculator. So you're going to do second vars, and you're going to scroll all the way down to part A. Okay, so part A and part B. So A is binomial PDF. Okay, and the way that it's handled, it's the number of trials. So that's the number of people you ask. So in this case, we asked 15. My P is 0.3. That's a probability. And my X is 4. That's the number of people who said yes. Okay. So the way that I write this is binomial PDF 15 comma 0.3 comma 4. I hit enter and I get approximately 0.2186. Okay, so when you see the word exactly, that means PDF. Okay, now part B, they ask us fewer than 3. So that is CDF. So we're saying up to less than 3. So it's actually going to be 2. So let's explain what's happening here, right? So if you have a hard time kind of envisioning it, write up all the numbers, right? So the possibility of people owning a tablet out of the 15, right? You could have 0 people, you could have 1, you could have 2, you could have 3, you could have 4, right? And so forth, all the way up to 15. Okay? Now, if you look at what we are being asked, is we're trying to find probability that fewer than 3. So I'm actually trying to find 0, 1, and 2. Okay? So how do I calculate this? I could do PDF where I add up 0, 1, and 2. So I do binomial PDF of 0 plus binomial PDF of 1 plus binomial PDF of 2. Okay? And that's not, but that does work. It's just going to take us a very long time. So the easier thing is I'm going to do binomial CDF of 2. Okay? Because I'm doing binomial CDF of 2, I'm really saying up to 2. Okay? Notice I don't include 3 because 3 is not less than itself. Okay? Oh, whoops. My apologies. Sorry, the first one should not be 2. The first one should be 15. And then 0.3 and then 2. Okay? So let's talk about how it's formatted. So first number is your total. Your second number is your probability, that's your P, and your third number is the number of yeses. Okay? So we're saying there's 50 people, there's 30% chance, and then up to 2 says yes. Now if it's PDF, we would say exactly 2 say yes. Okay? Or in this case, exactly 4 says yes based off of part A. Okay, and then my answer will be 0.1268. Okay. Okay. Let me continue with part C. It's the same exact problem, okay? But yeah, they may throw something like this at you. So it says find a probability that more than one person owns a tablet computer, okay? So let's understand what's happening. So I'm going to write all the possibilities that could happen, right? 0, 1, 3, and I'm going to count all the way up to 15. So I'm visually figuring out what's the possibility. So if I say more than one, right? If I look at the picture, right, it would be this right here. Okay. So right, if it's more than one, it's 2, 3, 4, 5, 6, all the way up to 15. Now, remember, bind CDF goes to the left. So I cannot actually use the CDF to help me figure it out. However, I do know I can subtract this part here. Sorry, I'm going to do this in red. I'm going to subtract this red part. Okay? This here is going to be the following. Sorry, let me give myself more space. So this red part here is binomial CDF. Okay, it's not PDF because it's PDF, it'll be exactly 1. So since it's less, it's 1 or less, right? I'm doing 15.3 comma 1. Okay. Now the thing is, I'm not trying to find a red. I'm actually trying to find a black. But remember, if I add all them all up, it would actually equal to 1. So in order to find a black, I'm subtracting 1 from, subtracting my binomial CDF of 1 from 1, okay? Now here's a way to help you understand. This is very similar to normal CDF, right? If it's going to the right, you subtract it from 1. If it's in between, you do the larger minus left, right? The one on the right minus the one on the left, based on the last video, okay? So I'll do the binomial CDF first. I'll throw this in my calculator first. Second vars. Go to part B. 15.3, comma 1. Hit enter. I'll do 0.035. So I do 1 minus 0.035. And this is equal to 0.964. That's my final answer right here. Okay. So let's talk about one last situation with binomials. Let's go over, I'm going to scroll down to, yes, a problem like this, okay? So number 15 says, in Toronto, Canada, 55% of people pass their driver's road test. Suppose every day 100 people independently take their test. What is the number of people who are expected to pass? So let's talk about this here. Okay. So when you see the word expected to, a lot of times, they're asking you for mean. Okay. Formula for mean for binomial is n times p. Okay. Now, This is where things can get a little confusing in statistics because you actually have certain words that mean multiple things. So mean, you got to be really careful because, right, when we think about mean, right, originally you're talking about adding numbers up and dividing it by number. You're trying to find average. Now there's a lot of different other words. There's a lot of other different definitions for mean, okay? And you'll find that out pretty soon in chapter 7. So how do I know when to use this n times p? Well, remember, this is mean, just talking about binomials, okay? So if I look at the problem above, I can see it's binomial because I have a finite sample, right? And I also know I'm talking about number of people I'm asking, which is discrete, and I'm trying to figure out if they pass or not, which is 2, right? There's 2 outcomes, okay? So since I'm trying to find a mean, it's a mean in regards to a binomial, so that's n times p. What is n? Remember, n is your total, which is 100. And then p is your percentage, which is 0.55, and that's 55. So the formula itself is not that difficult, okay? You just have to know when to use it. So remember, this is a mean in regards with a binomial. So expected also implies mean, okay? Now, standard deviation, remember, this is standard deviation for binomials, okay? Context is key, okay? You want to understand what the situation that they're asking for because obviously there's a lot of different types of standard deviations. So it's a standard, so once again, it's a standard deviation for a binomial, and that is n, so that is equal to, standard deviation, the formula is square root n times p times 1 minus p. So that is square root of 100 times 0.55 times 1 minus 0.55. Okay. You should be able to throw this all in your calculator. Let me show you how. So you can do second, so yeah, to find a square root, you're going to do second x squared, and then it'll be 100 times 0.55 times 0.45, and hit enter, and you get 4.97. And that would be your answer here. Okay. If you have questions, feel free to post on a discussion board. But yeah, or you can send me an email. But other than that, let me know.